Hello, Dr. Vidyasagar. How are you?
Yeah, hi. I'm good. What about you? I understand that you were traveling last 2 days.
One moment, please. Yeah, yes, please.
Yeah, I understand that you were traveling for some event.
Haha, there is, some master classes happening and by the UP Pharma Promotion Council Conclave. And
Acha.
I'm being the faculty, I had to go there for the training.
Oh,
For,
that's great.
for being giving training to the doctors and other people, those who are not actually updated or aware about ISO 14155.
Okay.
So this is all about the how to manage a clinical investigation of a medical device.
Okay, okay.
Hmm. So that's very nice, and I'm done. It was for 3 days, Saturday to uh, Tuesday, and then I returned. So in between, I missed your classes.
I'm
And
not sure. I mean, like I have shared the recording, no? You can go through it. In case if you find difficult to understand or you have some queries, you can come back to me. I mean, I'm available. Like.
yes, yes. Actually, I got the link, but
Mhm.
I'm not getting the material in that link.
Acha, I'll share that material.
Achha.
Uh, because that is a video recording of for the lecture.
Hmm.
Material I think I have shared in the group, or I mean I'll check it out. If I am not shared in the group, I'll share the material in the group.
Please, please.
Yeah,
Thank
sure. I'll.
you. Recap summary, na? Okay. Uh, Dr. Vidyasagar, I would propose you after some time, if you
Yeah.
can meet our managing director, okay,
Sure.
so that, basically, even if I need to involve my team
Mm-hmm.
and want to introduce something new, then I
Mm-hmm.
must inform him well in advance. Accordingly, the message will, be channelized from top to down.
Sure, sure, sure.
Huh.
Yeah.
So,
What we can do is like, I mean, let me know when you are free to connect.
mhm.
Okay, I'll call you.
Uh-huh. Sure, sure,
Yeah.
sure.
Then we can discuss on what I mean, what how we can collaborate and how we can do better, like even in your domain or wherever you go.
Yeah,
For yes, I mean, I could really help you on that.
absolutely. Understand. Sure. I will give you a call back.
Okay, okay.
Right.
Just or yeah, call me anytime. I'll be there.
Thank you. Thank you so very much.
Yeah. Hi, Kirti.
Um,
Yeah, where are you? You're in Bangalore?
into traveling Hyderabad.
Traveling. So why you are now back to Hyderabad?
Yes, I worked 3 days in Bangalore, like Monday, Tuesday, Wednesday. Wednesday I
Okay.
travel back, then I return on Sunday.
Acha. Okay. Oh, I mean, just wait for another 5 minutes. However, during this time, those I'll share one MCQ. I mean, it could be some 8 or 9 MCQs.
Hello, sir. Good evening. How are you,
Yeah, I'm good. What about you?
sir?
Good.
Yeah.
Can you see my screen?
Yes.
Okay. Just try to read and understand the questions. I mean, check out the choices. I mean, it's just to make you understand like what could be the right one, or make you digest uh, the questions or the purpose of why this AIML is not to grade you or rank you. Plus, you can provide your answers in chatbot. Okay. or in the chat option. Like these are very basic, simple questions, which we have covered in last 2, 3 sessions. Okay. I mean, again, I'm saying like if it goes wrong, that's fine. I mean, starting only, I said there'll be a lot of stupid questions, stupid answers. It happens in AIML. And I also see like when I'm learning AML way back in 21 in Texas, I mean, there is particularly you see like there won't be one right answer, or you can argue, you can justify some other answer. These things happen in AML, like in your regulatory or quality, we basically try to have only one answers in MCQs or in some of the clause or section. But in AML, it's quite different. You can justify like saying that this could also be right, or say that is wrong. What I said could be wrong, or you can defend your question to the answers in a I mean, it's like in a different scenario or in a different case study. You may say that this model can also be applied. Okay. I mean, just go through the questions and try to understand them. And meanwhile, I think others will join. I understand like some are traveling back from their office. Okay. Yeah, Pranita, for you also go through these MCQs and try to understand the questions and the choices. As I said, like you'll find the best answer, but there could be multiple answers. You can debate with me, but try to attempt and answer it in chat. See, from question one, it can be debated. That's the reason I gave questions which could have multiple options or can be debated. I mean, that's how AML works. It's not like there is a gold standard or a universal answer for anything. It's more on the logic and how you understand the models and the system. We take 10 minutes to go. I mean, I said like first you try to understand it.
Okay, if you are done, like, okay, we'll go ahead with our session. I mean, I shared that MCQs just to make you understand that how different models can be worked out in different scenarios. And I again repeat, like, it's not something a standard or gold standard rule that you have to use a particular model for a particular activity or particular task. Okay, you can work on almost all the models, but end of the day, you need to choose the best model. That depends upon a lot of understanding. Okay, one is on the data you have, whether it's a complex data set with 10, 20 variables, or it's a simple data set. Just you want to do a linear regression or a classification, yes or no, or probabilities. Okay. I mean, as we move further, like, you find really more interesting ML models. Okay. But I want you very specifically to understand, like I said, supervised, unsupervised. Okay, in supervised, again, I'm repeating, like in last two classes also, I said, like, basically we look at linear regression, which we have been working since our college days. Okay, it's simple XY scattered, but there is a lot of information in this linear regression equation of a straight line, how scattered they are, and a lot of things you'll get from the ML model. It not only gives you the linearity or correlation coefficient, how the points are aligning, but it speaks a lot. Okay, I mean, the important data in the uh, uh, linear regression is not the data which is in line with the best fit line or with the line of regression, but the data which is scattered for a QA person, basically for QA, but also for RA. I mean, in some of the things like the
field safety corrective actions or some data that includes PMS or complaint handling. If it is a new one that doesn't fall in line, you will have a lot of data scattered, which means that your complaints or your rejections are not the same. Okay. If the rejections or the complaints are the same, they fall in the same line. Suppose you have 10 data points and all are pointing or sitting on the line of regression or the best fit line, which means you are getting more complaints. That's what the trend analysis says. But it importantly says that all of them are the same complaints. But if they are very scattered, okay, I mean, you have multiple applications. I mean, you will be very thrilled to understand once you have hands-on experience in working on these models. The data that it generates, the output it generates is so classical, in-depth, okay, it has a lot of breadth. You can interpret a lot of things. I mean, like we discussed on supervised, unsupervised. I also discussed on decision trees like the random forest, which is a bit more evolved and bit more updated. Okay, and also upgraded random forest or decision trees. Okay, that can also be used. Okay, that comes under again unsupervised learning. Okay, we discussed about object detection and computer vision. These are a club of ML models. Okay, linear regression, logistic regression, computer vision, object detection, decision trees, random forest. Random forest and decision trees are the same. In random forest, you will have more decision trees. Okay. While we work on some of the examples, which I'll explain to you some of the examples also. What are the best fit models? Okay. For our QARA applications. And I also tell you the limitations of the models and what will be the auditors asking on that, okay, on the models and the probability of that models giving wrong interpretations or what you call as drifts. I said like you'll have drifts, you have hallucinations, you have black boxes. Okay, these are some of the concerns with any AML, whether you use it in any domain. Okay, but again, I repeat, like ours is a regulatory domain, and we are dealing with a very critical, okay, very critical activity as a QARA guy, okay, and trying to, I mean, not to compromise on the patient safety. Okay, that's the final goal of any QARA person, that we should adhere to the regulatory guidelines or regulations of any country, okay, and be compliant to it. And end of the day, I mean, bottom line for us, patient safety is important. Just because these models are available, don't, I mean, use them as you like and deploy them in your organization. Once you have solid understanding and you have data, okay, you can keep playing with it, but the outcomes you need to be very clear. Okay, you should have the explainability to say that the model I have trained it, I have validated it, and I have tested it, and we got the right results. Of course, I'll tell you with examples and later part after, I mean, showing the examples like stepwise, like how you need to uh, uh, provide your data to the model. I mean, basically like where we can get the data, how to clean the data. I said, if you don't clean the data, other day I was talking on, there will be some missing data for some variables, but those variables are very important for the decision making. Okay, I mean, the model may go wrong, the trained model may give wrong results. So you need to clean the data and you have to be very well satisfied with the data that you have included all variables, okay, and also you have randomized it, then you train it, validate it, test it. You can test multiple times whether it's giving the right result, because it's just a 10 minutes job once you understand how to go ahead with this. Okay, I mean, uh, it's about linear logistic regression, computer vision, and these are very old models. The upgraded model of computer vision is the object detection. I said object detection looks not only at a particular boundary, it looks at the surroundings also. Okay, I mean, it can align, this can be really used in a lot of mainly in the QC. Okay, when you look at the component, whether it's properly aligned, you can also use in R&D in your prototyping. Okay, you can do a lot of clinical validation or digital twins, that whether they are really matching. If they are not matching, what's the difference? You can work on with your predicatives. Okay, you can have a lot of design inputs from them. That's the most updated of the computer vision is the object detection. It detects every object. Like you are very well aware of the general applications what we see in our everyday life. I mean, that's what I best quote what Amazon is doing on object detection. And the best way to understand is like what Elon Musk is doing on the self-driving car or autonomous cars. Okay, it's basically an object detection. It detects every object that's there in front of you while you're driving. Okay, but it has to be pre-trained. It's not like that trained in US can be brought directly into India and we can drive on our roads. On our roads, I mean, I think it takes another 10 or 20 years to have self-driving car. But EVMs are fine. They don't understand this AIML. So what? Sorry. What I'll do is I'll go to more advanced. Okay, apart from these 5, 6 models which I said, which are more advanced models. Okay, because we are talking on advanced AIML. These 5 models which I have discussed, you can easily work on them, give your input data, train them, okay, and give the test data and try to understand it. Okay, it can be done in 10-15 minutes, like what's the outputs are. Okay, but I mean, if you go at the advanced models, as I come to you, let me share that slide. And I really oblige for not sharing the material as requested by Shushmita. I mean, I'll do it tonight. Remember, I don't know like how many of you are finding time to go through the recordings, but it's, as I said, I mean, I posted it on WhatsApp also. It's very important that you have to have connectivity between session to session, because it's almost a week time. I mean, we have session intervals. So I said like until you practice them, have hands-on experience on these models, okay, you will have a bit of ambiguity on that. You'll have a doubt on yourself, can I really do it? But I promise you, I'll make you understand them and also make you to work on these models. Okay, and you'll be, I feel so excited. I don't know like how you feel after working on these models and getting the outputs. It will be really great. Like, but again, I said like we have some limitations. Okay, the other side of the screen or on the coin, you need to understand that and have what I was repeating this word, okay, that is what we call governance over the models, what we are adopting. You should regularly keep pre-training them, trying to understand that your train model is there, or there's total cyber security on that. There are no drifts that are happening. There are no hallucinations because ML, some models like the advanced models have a memory, like the generative AI. Okay, it remembers what is your last conversation. And if you come out with a new conversation, mainly in the clinicals, you see LLM models, large language models, using generative AI or ChatGPT like Grok or Perplexity, like even Gemini. They have some memory and they'll come back and remember it and answer your whatever prompts are there, okay, in a way that you have worked previously with that memory. Though the prompt may be very different, but it will connect to the other one. So I'll also tell you how to work on the prompts when you are working on NLP and LLM. That I mean, LLM is the advanced version, large language model is the advanced version of NLP. Okay, as I said, object detection is the advanced version of computer vision, and random forest is the advanced version of decision trees. Okay, so today what we'll do is we'll try to understand a little bit complex models, but they are also used uh, in our medical device domain. But what you feel, what auditors or what the investigators who come is they will be happy to see you using these supervised, unsupervised models, linear logistics, object detection, or CB, and even the decision trees, random forest, because they will be very comfortable to understand the core concept of it, and you will have a lot of explainability. I mean, you can explain to them that this is what the model has done, and it's easy for them to understand the auditors, and we are compliant to the regulation. As we navigate to the higher models, it will become bit complex, but still you can use them if you really understand and can have the explainability, governance over it. Okay, not having any risk with the model. Still you can work on it, but human loop, I said it should be human centric. You need to take the final call or the decision, not the system or the model. Okay, this I said we'll discuss few models like NLP, okay, LLM, because these are also of late very much used in our domain and also in a lot of other domains, okay, which doesn't come under our umbrella. And the other thing is like these are going to be the advanced model which will be in place actively, I mean, involved in all of the activities, okay. Maybe in next 1-2 years everything will become so autonomous, okay. But I still say, and we need to have a consensus that it should be, I mean, human centric. I have told you, like the industry 5.0 is more an hybrid intelligence, okay, where the machine should support the human intelligence or AI should support the HI. It's not like AI takes all the decisions. Human loop is very, very important. Okay, but in other domains, it could be autonomous, like it runs everything, it takes the decisions, It can go to the next task or next activity by itself. Okay, the objective of how you train it, how you feed it. Okay, it can find its own objectives, goals, and how to achieve them. It could be simple to complicated. I'll come to that. That are also used in medical devices. Okay, natural language processing is simple. I mean, like how you use the Google Translator or some translators long back. But this is of late was very much used. I mean, not in India, but in Western countries where you have large data. Okay, what we call in AIML big data. But processing the data takes a lot of time. Understanding that, like I could quote a lot of examples, like in your complaints, okay, which one to figure out, or in your customer feedbacks, or in your clinical evaluations, or I could suggest Sushmita ji to work on this on even your clinical investigations, or even clinical reporting, not just in our domain, overall in the healthcare sector. NLP are basically used, okay, to process large data, like hundreds and thousands of the input data can be provided. Okay, what it basically does, I mean, we are restricted to our domain. I can talk of it like how people use in other domains also, like in retail or in other domestic manufacturings, like in pharma, how they use it, how they use it in other automotives, or in the banking sector. People use this. Okay, this is the one which NLP is the one which gives you what we call for the banking management or the banking system, whether the loan has to be approved or not, based on the NLP only. And your CIBIL score also depends upon NLP, because we understand it very much. That why I'm quoting how the CIBIL score is derived from the NLP. Okay, based on your EMIs, when you paid it, when you have not paid on regular, it will work on that system. I mean, when you look at that models, you feel so interesting that this NLP or LLM is doing that work, or object detection or computer vision is helping in self-driving cars and a lot of other things. That because since it connects so much to our real life, you feel like good. Okay, but this is more of a professional thing, which we need to understand it with so much of clarity before we employ or deploy them in our workstations. Okay, this the word itself is a natural language processing. Okay, it enables machines to process, analyze, extract meaning from a human language, text or speech. Okay, it will extract information. I mean, you would have used it. It's easy to understand. You can use NLP in any, I mean, like a lot of apps that are very free. Okay, off late, many are offering apps at free, because there is a competition between these big MNCs, which provide the best on things. I mean, we can also work on but the main point, it processes, analyze, and extract meaning from human language. It will be I'm a bit surprised when I say how can it extract meaning. Okay, but it will be really interesting to understand how it extracts meaning. Of course, it's a mission. It will work based on how you provide the training data, or you pre-train them. Okay, all our generative AI GPTs are pre-trained models. Well, like how you get the answers is like it is fed with millions and millions of data. I mean, that's what there is a growing concern about data centers. Okay, all the information, what we are logging in, whether it's your drive or whether it's placed in cloud or your drives, everything is there in the data center, stores in the data center where you need to retrieve. Okay, like even the generative AI, okay, for most of us, the common is the ChatGPT or Gemini or Pro, or in India, Arvind Srinivas, Perplexity is the one which he has come out in India on this GPT. These are all pre-trained where it has already total data in them. Okay, so whatever you ask, you'll get it in seconds because the information and data is there already provided in them and they stored in the data centers. Okay, of course, I mean, if you need to go for the more advanced GPTs, you have a premium or you need to pay for it. Okay, and there is a lot of concern of using it for professional work because cybersecurity is one issue, like your data may leak to others. And there are some issues also with these advanced models, basically on the what we call the correctness or the genuinity of what it is providing. Okay, some we take it on the face. Okay, some we review, some we think that it is right. But I would say you need to have a lot of caution before you use this, mainly NLP and LLM. And I'll come to agentic AI and AI agents. Okay, these three, like deep learning is also a very interesting model which we discussed, which involves similar like decision trees or random forests because it has a hidden layer. It thinks like the human brain. That's the importance of deep learning. These models, advanced models, also come in deep learning. Okay, it thinks like the human brain neurons and it processes them. Okay, but the point is that you need to train them and make them, I mean, I say again, I repeat, this is a common word, like you should have a governance over them when you are training, validating, or testing. And most importantly, guys, I say like in the medical diagnostics, like a lot of devices, what we are using in SOMED or SOINMED, software as medical device, or software in medical device, you need to be very, very careful. Okay, when it is linked to any machine learning platform. Okay, if the algorithm or the code goes wrong, you will have a lot false positive results. Okay, and the diagnosis will give you absolutely, I mean, I could say the worst results that affects a patient's life. Even I know like two of you are there in the surgical robotics and some on Davanci equipment, which is basically a SOMED like. That is a more complex and some I'm also covering this genetic and agents and agenetic AI because some of the robotic surgicals do some autonomous work. Okay, it's earlier 2 years back, 3 years back, it is some part of the surgeries they used to do, okay, critical surgeries, uh, and the other part with the specialized physician or the doctor who is to undertake that. But of late, the surgical robotics are also becoming so autonomous. They are so trained, like they work much better. Okay, the efficiency is fast, and the outcome of the surgeries is also better. Okay, of course, Devancy, your system of Intuitive is for the automatic stitching of the wounds and other things. But real surgical robotics that perform surgeries on vital organs Okay, or there are a lot of competitors Metronic is one which is coming very hard on this. They are moving very fast because they are collaborating with a lot of these MNCs who are working in AIML, like the Google or the Meta. So this, and the point here is like we are looking at NLP, which has a wider applications and bit advanced than what we have discussed earlier. The point here is like it doesn't understand the language or the text which we have provided. Okay, it processes your whatever data you have given, whether you have given it a PDF or a Word copy, or you fed with some input data, or you in LLM you type it on chatbot or in your GPTs. Basically, NLP doesn't understand what you have written or what is fed into that. Okay, it does not understand your language, but it processes on a definite principles which it was trained. Okay, what we call it as statistical patterns in words and sentences. But how it understands is like it converts the text into numericals. Okay, it doesn't understand the alphabets, whatever language it is. Even it doesn't understand the most used global language, English. But what it does is it identifies the patterns, okay, of the text what you have provided. Like what are the words most repeated or what are the sentences most repeated. Okay, and it converts them into numericals and forms a pattern like these are the words that are repeated. Okay, that's why you need to be very careful when you're training them. What are the specific words that are used? Suppose like in complaint handling, what are the words you use in providing the input data or training in the complaint handling? Like, okay, this complaint is so and so. This is the word or text. It has to be very much standardized and validated, because your text data also should come in the same language or in the same sentence or in this basically the same wording. Okay, not necessarily the verbs and the pronouns, all that it may not consider. Okay, the verbs or nouns and pronouns, but it will get the exact phrase of it or exact word of that. Okay, and it will form a patterns of that word or that particular sentence. What it means, meaning is informed from context and frequency, not comprehension. Okay, what is the context that you are speaking about? But suppose I have given the data for me to work on a clinical investigation, which says that this is my device is superior or equivalent or inferior. We do a lot of things on that. Like when we test the devices, when we have a two-arm, what we call the clinical investigations, trying to work out with your predicatives or the global innovators. Okay, we have a double-blind two-arm studies trying to match, and we work on a lot of non-inferiority or superiority. Superiority is very difficult, but at least an equivalent non-inferiority is fine. Okay, when we get the data, it picks up what is the exact endpoints you are deriving at the primary clinical or the secondary clinical endpoint or procedural success points. It picks up them, not the total comprehension or the text you have provided. Okay, it doesn't take all the 100 pages what you have provided and try to read it. Okay, it picks up exact phrases or sentences. Okay, in them it extracts some words, and that words will be turned into numerical and it forms different patterns. Okay, when we work on, some of them, this is what Amazon provides us free. That's AWS, you can check it out. like you can provide something to it, it will work on that and tell you what is the most common word that is used and what is the context of it. Okay. I mean, most of these, I mean, to give you a common example, most of the what we call, I forgot. Uh, I'll tell you. I mean, what we call it as sentiment analysis, whether you buy from the online shopping or yeah, that's the OTPs. I watch daily and I forget. There's the OTPs. Okay, how it derives at what you want. Or the Amazon tells you that you are looking for this. Based on all the sentiment analysis or what we call NLP, what you have purchased earlier, what is the range you have purchased, what cost you have purchased, and it will advise you before you go into that. Okay, what do you want to purchase? It already provides you a lot of information that these things are available for you. And it varies from person to person, from what you're purchasing, what type of things you're purchasing online, or the groceries or clothes or something, vegetables, or it will give you based on the NLP only, it works on that and provides you a patterns like, okay, this guy wants this, and which movie he like, okay, he likes some horror, science fictions. It provides that movies when we straight away enter. And it's not a magic that is happening. It's working through some ML models which has your experience memorized or recorded through NLP. Okay, and it provides you predictive like what you would like to see. First, if you like something like historical movies or something like which are war related movies, it gives you all that. Okay. And this is, we will work on that. That's what I'm telling AWS. That's what Amazon uses. AWS mainly on, just a second. Hi, Arunati. Hello. Yeah. All good? No, you are checking it. Yeah, I'll share the link. Yeah, in a minute I'll do it. Just give me a second. Some of our participants are not able to open the link. I'll reshare. Yeah.
So join, sir. I just went in a wrong link.
No, actually I shared again, but when I share from, I don't know, like what's the problem? When I share from my laptop, it's not seen in mobile. I mean, I think there's some discussion action that's happening with Android and the laptop software. Could be some Windows 5 or so. Yeah, I'm sorry for that. Okay, I said like it doesn't go through everything, but it takes up some abstracts or sentences from it. Okay. And it takes it as, I mean, like any data, what you provide as an input data. Okay. And you need to be very particular that it doesn't understand what you have given to it. Whether you have given a clinical document, whether you have given something linked to some other regulatory activities on design, or whether it's on technical documentation. Okay, but you need to make it. I mean, as I said, like you can label it also. Okay, label it like say that this is the one which I'm providing you, because I said like it has a memory, it can understand, but you need to make it into a lot of branches. Okay, like you can't use the same model for all activities. Okay, you need to branch them, number the model, okay, NLP model 1 or something for that particular activity, and you need to give your test data to it after training or validating, so that it will be in that particular boundaries or in that particular box, so that it remembers that only, and it does not interfere with other data which you are providing if you mix up. Okay. So for us, it helps in, as I said, I discussed, we can address a lot of complaints. Okay, once you have the complaint handling report or the complaint form, just you feed it, okay, it will derive a lot of extracts and it understands what is the complaint. And further, it also provides the classification of which complaint it comes and whether it's device related, okay, whether it's I mean, usability link, like whether it's also has problem with other compatible devices which it is used of, or there's some problem with the doctor or the physician. Or it also try to understand not the root cause, but at least do the triage. Triage means the initial assessment of what this problem could be. Okay, on the complaint. For root cause and all that stuff on that can be also be done, okay, in deep learning to find the root cause when you have, but this is very much useful for handling the complaints, classifying the complaints, and also providing the triage of the complaints, uh, which category it falls, okay, and how many times it's, I mean, I don't know, I can tell you 2 3 points like classification, what are the complaints, how many times it has come, or particularly which hospital it is coming, or to which component it is linked. Okay, more than this, based on the variables you provide, it can give you, I mean, a lot of outputs where you can understand. And also, since it is forming patterns, you can find the layers of that. Okay, this is the first high risk one, this is the second one with the risk. You can do the classification of the risk of your data. Okay, and it proposes a lot of other things, like why it is not happening with all devices, only few devices are just having complaints. Okay, I mean, as I discussed, like why devices fail. So all of them are compliant or have the conformity assessment and also have passed the QC. But still some of the devices fail. That is a very complex thing which we need to work on the root cause, get a lot of information. But the ML thing, like if you combine natural NLP with the deep learning, okay, I mean that's the beauty of AIML. You can combine two options, I mean two models to arrive at something much better than what one model is doing. Okay, if I say like I said in convoluted neuronal network, that is the deep learning. If you connect CNN, okay, that's the deep learning one with the NLP, it does a lot of work even to find the root cause. Okay, and if still you further align with some other model like which I'll be talking, okay, it can also suggest you whether it has to go through a corrective action or a preventive action. Okay, like whether you need to address that immediately as a corrective action or preventive action. And I was talking to a lot of people. It also gives you something like on predictive compliance or predictive analytics. It can predict like, okay, in this batch, how many could still go? It may not be 90%, 100% accurate. It could find based on how you train it and how you validate it. If it goes up to 90%, that there could be some more in this batch with these numbers that can go wrong. Okay, you can recall them or you can give an advisory notice, further stop using the device. Well, these are, I mean, some of the things which really helps you. But I feel like this saves not only time, but also on more what we call today's compliance, okay, or what we call is not just on the regulations, okay, or on the just on the copper, but it's more on the prediction of what I say, predictive analytics, like how you handle the complaint, how you handle what's going to happen. Okay, it's more a prediction, like it's preempting the what is going to happen. As I deeply understand what is preempting with the intelligence bodies of a country, like we have RAR, the most intelligent, the best intelligence body in the country is the Mossad of Israel. Like they do a lot of preempting wherever you are in the world so that their country is not affected. Similarly, like this, we can preempt a lot of complaints, which is really good looking at the safety of the patient. Okay. Before it happens, okay, most proactive approach, then working on the corrective and preventive action. So what I would like to make you understand is like NLP does a lot of work, but when you connect it with other models, like say on the CNN or physical CNN convoluted neuronal network is a very well built model. Okay, it's not so new. It's there since I learned, but it gives very good decisions. Okay, you can collect a lot of models, not just one, giving you some triage or early primitive data. You can get more advanced outputs when you connect a lot of the ML platforms to one. And I'll tell you like how you can do that. Like when we enter into agentic AI or AI agents. Okay, you can work on complaints, CAPAs. This is what I'm telling, risk stratification or risk classification. You can do, a lot of people of late are doing, okay, with NLP, the clinical, collecting the clinical literature, literature, doing the clinical evaluation report, but mostly they are using LLMs, not NLP, but still NLP is also valid. Okay, working on the regulatory guidance, IFUs, I'll tell you all this when we really work on these models, okay, upload our data, I'll tell you like how it can provide regulatory guidance, how you can get updates, okay, everyday updates on what's the regulatory model that has come in, okay, today, what are the updates or the amendments that are happened to all the regulations, or including, I mean, even it's quality related, ISO related, or regulatory related, anything. Okay, you will get your updates, okay, and you can be compliant to what's happening in the real world, not somebody feeding you or somebody appraising you that something has happened or some regulation has changed. Not only that, it gives a lot of updates, and it also provides something like whether you have compliance with that new regulation or new update, okay, or it's a previous one old update which has been repeated. Okay, I mean, it can do a lot of such things. When you integrate your workflow with some of these ML platforms, ML models, but again, I come back to the same thing. You need to spare, I mean, you should not blindly believe what it is, I mean, advising you or taking the decision. You should read it and try to understand. You should have some expertise on the domain. Okay. Just don't take it at stake that it's really doing great work. Okay, this I say humans like human intelligence is better than, I mean, compared to a lot of attributes that are there. Human intelligence always excels. Okay, there are some areas where we talk of empathy. I mean, other things. Of late, I don't see in humans also all that, but still, it's okay. It's not there in machines. Of late, we don't have it in humans. It's not no different, but still the decision making has to be done. But the problem why NLP has become so prominent is we are slow at large scale text review like Medtronic or Intuitive or Abbott or J&J. They will be having multiple, I mean, plants or multiple markets. Okay, multiple manufacturing, what do you call SUVs or a lot of verticals. So there will be a lot of data pouring in day in, day out, every hour. So it becomes complex for them, or even for some of the Indian companies where you have even the SMEs now adopting to this, okay, to process it. Because why SMEs are adopting is there is an very good reason, okay, apt reason, like if you can adopt this from your startup or initial stage, okay, you can deploy it very easily and you can further augment or progress on it. Okay, instead of say after your company grows, it becomes difficult to implement so many activities, so many models at a time, and there will be a lot of what we call crossover that happens, and it's very dangerous. Okay, but you need a team. Like it's not like we alone can work on that. There will be some data scientists or the model architectures who can help us. But later we need to take control of it. So I basically advise even the startups to adopt, because the next 2-3 years you see it's really happening. Okay, and it's not a dream. It's a dream come true that it has happened in last 2 years. Okay, and it's going to happen in, I mean, no domain is excluded. The percentage of entry of these models depends on what the domain is. Of course, like in healthcare, we need to be very careful. Okay, inconsistency, it's okay. Miss weak signals. It can catch weak signals also. Some we may miss. So I say like there is a catheter with a pinhole, but it's not really regarded as a complaint. Okay, it's not affecting the patient. No direct impact on patient safety. Generally, we say that it's fine, we'll neglect it. Okay, even in medical equipment also, we consider a lot in medical equipment, it happens, medical diagnostics happens. We consider a lot of them not so significant that could really impact. But the good thing about AIML is like once you deploy it, it finds even the weak signals which you have not captured because it can propagate from what is being addressed as to be a risk element. It understands what is the basic risk that complaint has been arised. It can propagate and link it to the weak areas or weak signals where you haven't understood or caught it. That may later propagate into a major complaint. If you have not addressed that, okay, in future there is a chance that the weak signals or the weak complaint. When I say signals, I mean there are different terminologies we can use. Like in pharma, we use like early signals or signal transduction, all this thing. But I mean anything that is not we feel linked to it, it can propagate, and that's one thing which we humans are. I mean, can be a best expert or good in that domain on root cause analysis or copper. Sometimes we miss it, but machines doesn't have any work except doing this. Okay, it reads NLP exists to read large volumes consistently, identify patterns and trends, support faster data-driven decision. You will get the, you will get the decision or whether you want to recall or you want to address it as a complaint, all this stuff, or regulatory advisory notice, you will get it in just fraction of minutes. And this is what I said. Text is not language. NLP system, it is a sequence of symbols. Okay, these symbols, it takes it as a symbol. Okay, then it converts them into numbers. Okay, it can, when I talk or when I tell you like how these numbers, the text is extracted, it turns into symbols. Okay, and the symbols further converted into numericals or numbers. Okay, for the symbol which appears same, like you write A, B, C, or in a particular sequence. Some like it could be some complaint which you have mentioned. Okay, it finds that symbol, that text as a symbol, and that particular word or a particular alphabet, it converts them into a numerical or a number, and then it finds the patterns in that. Okay, of course, I say that NLP is been there, it's not so advanced, but large languages are very active. LLMs are very. The conversion is the most critical step. This is what the core concept, but there is no need for us to understand how it does. Still, I'll give you an overview on that. How this text or speech. Okay, basically even speech also we need to understand. Speech is converted into text, and text are generated as symbols. Symbols are further propagated as numericals. Okay, it's a complex thing to understand for us. Actually, it's not necessary for us. Just we use the model for our applications. If somebody wants to understand how it does, then we need to go back I mean, dive deep, more in depth, try to understand some language on coding, how you write it. Okay. So this is what I mean, for us complaints, reports, emails, PDF databases, I told you, it can extract a lot of things from your emails. It can, if you provide, it's an autonomous, it will also reply based on what's the content of the email you got. It can provide appropriate replies to your emails, extract the PDF databases. Yeah, database is basically very useful in clinical evaluation report. You can go to something like Mode or usfda.gov and you can code like this is what I want. Okay, it keeps extracting because in Mode you have millions and millions of data on the basically on the complaints or FSCs or adverse events, all that stuff. Now you have in Europe the Udemy. Okay. That is, as I said, text acquisition, text pre-processing, cleans up and removes all the verbs or nouns or some pronouns. Okay, it's a pre-processing. Punctuation, normalizing case, removing irrelevant words, correcting spelling. But there is a danger if what is the essential important word is also removed. But I do understand, like I have worked on this. It doesn't do that stuff, but there is a chance. We can't blindly believe these machines. Okay. Then the text is broken into smaller units, words, phrases, subwords. Then it goes into numerical representation. Okay, it converts into numbers, wherein most NLPs have behavior originates because they have a memory. This is also called, you have a bag of words. That bag of words are converted into numericals, which are much lesser than your text because it has done all the pre-processing, has done the processing conversion of this. Okay. As I said, NLP is simple. You can explain it. Okay, explain it better. I'll share this. You can explain to anyone how NLP works. Okay, like I said, even for the auditor also we need to explain when he says, I have done this through NLP. I'll tell you like how to address the auditors. For all these models, for all of the activities, when auditor asks a question, okay, how we need to provide the justification. Because I don't know whether I discussed with you or not. As per the EU AI Act, or even if you look at EU MDR or the FDA, US FDA, these ML models, okay, are accepted for a lot of activities in the QARA. Okay, auditors also accept this because they are come under regulations. I don't know much about, but since the major regulations are accepting this, I know like CDSCO or IMD or medical device rules should also implement this. As I said, we had a draft document on this, but it's more on SOMED. Draft document on, it came in 2025 October, but it's mainly on the SOMED, not really with the AI-linked medical devices. I also told you of late, lot of devices are now linked with ML, AML. For quite a lot of reasons. I told you it could be a simple IoT or IOM, Internet of Medical Things for monitoring and medical diagnostics. Okay. So we can try to understand. It's easy to explain NLP, but you'll find difficult to understand. Like in this also you have, I mean, I'm just trying to make you understand, like word embeddings, modern NLP, that's That's the same thing what we are using now. Okay, it looks at the meaning similarity. If the two words are there which have similar meaning, it looks at the word and may give a combination of that. Okay, it's not like it will be repeated where there will be a lot of you need a lot of data storage. But if there is the same meaning, what we call word embedding, it can combine them and make it one word. We'll see that in AWS of Amazon, like on what we call sentiment analysis. I'm really surprised why it is named as sentiment analysis. But it's used in science also, in medical devices, a lot of things it is used, not only in the OTAs or other things like online shopping. Okay. Like you have failure, malfunction, normal, acceptable. These are clustered together. Failure, malfunction, it treats. That's what we call embedding, word embedding. Okay. Conceptual language models. This is an advanced NLP, wherein words change meaning based on the context. Okay. Failure in manufacturing is not failure in clinical use. So in word embedding, we have malfunction, two different words, but of the same meaning. It can do the word embedding, but okay, in conceptual language models, it looks at the whole sentence. I say it's an failure in manufacturing, rejected in manufacturing. And then you have something like a malfunction in clinical use. Generally, in word embedding, it has to combine both the words. Okay. But in conceptual language models, it takes the total phrase and understands the context of it. Okay, it's happening in manufacturing, it's happening in clinical use. So though they have the similar words or similar words of the same meaning, or perhaps even the same words, okay, it can understand the context. Okay, that's why it is called as contextual language model. And you see a lot of this now, like NLP is, as I said, it too has become so modernized, advanced, that it can interpret based on the context what you are talking. Okay, I mean, you can try this in your general works, but we can also implement this. The good thing in our domain on when we are working on QARA, like whether it's really, I mean, you can test it, whether it is doing word embedding or combining the words, or it is doing a simple NLP, okay, extracting and doing all this numerical, or it is also working on the conceptual things based on the context of it, contextual dependent meaning. Okay, this is for those who really want to understand this stuff. Okay, word co-occurrence patterns, phrase associations, conceptual similarities, statistical relations. Well, these all things, I mean, that's why you'll appreciate it when you know and understand a lot of ML models. Basically, I said ML is something which does a lot of work. Okay. But we say AI because AI is the one which takes decisions. Okay, that's why it's called artificial, but you should give credit to machine learning because it does bull work or donkey work. And end of the day, we call it AI. Well, AI takes decisions. It's good to say like AI is taking decision, but okay, I mean, word co-occurrence patterns, phrase associations, conceptual similarities, statistical relationships. Okay, how it is linked statistically. I mean, it can work on that mainly, as I say, when we use a lot of statistics in our QA also, like on the CPK or PPK or in the Six Sigma. But most of the statistics we use in the clinicals or in our PMCF, clinical investigations, real clinical setup. Okay, calculating the sample sizes or the level of significance, power of the study, a lot of things it provides. But as I said, they don't understand anything. What is the sentence? What is that? What is the context? I mean, what is that you have provided to me? It reads it, of course, it does the word embedding and conceptual understanding meaning, but it doesn't draw the regulatory intent, clinical reasoning, legal meaning. These are all these are problems with all AI models, not only with NLP. Okay, these are some text classification, like compliant time, which I already discussed. This is one what we call sentiment analysis. This is what I discussed. May not be much relevant, but detects emotional tone, negative, neutral, positive. Okay. It can understand tone. Maybe you would have seen this in some of the apps. Okay. In regulatory context, negative sentiment like safety issue, neutral or no risk. But that's not a big thing. Sentiment analysis is not such a great thing with our domain, but for other domains, it's important. Okay, it works in the same fashion. It pulls the text, does the text extraction, it does the tokenization, all this. Okay, some of these topic modeling. These are some, as I was repeating, complaint trend detection. What is the trend that's happening in complaint? Predictive detection. It's what is a early signal identification. You can identify early what's going to come. Okay, copper. Root cause clustering. Like when I said clustering is more linked to K-means clustering. It's a deep learning. I told earlier only when you link NLP with deep learning, it can do clustering also. It can tell you what is the root cause of this. Okay. There could be different. It can work whether it's a fishbone or 5i or the tree model. Work on different models. Okay. It can do recurrence detection. Recurrence, whether it's the complaint is repeated or the copy is, though the copy is done, still the complaint is coming out, which means the copy is ineffective or your verification, okay, is not proper. Regulatory independency, which I told, monitoring guidance updates, identify regulatory themes. Okay, it can update you day in, day out, like what's coming in. I use this for a different purpose on current affairs, but not on the regulatory updates. But don't deploy them, it will really disturb you, won't make you work. You keep on looking at that model only. I mean, you'll have 24 hours screen time. Okay, consistent. It's good. You can work on NLP model on consistency checks, whether you have used the proper. We discussed like when I mean, somewhere in ISO, it's important like in regulatory or in ISO, the language has to be, the words has to be the same, like ISO 9000. Okay, the wording or as you look at the glossary, you have definition. It can be fed, total 9000 document could be fed into this NLP, that model, and it uses the same word repeatedly so that like if I use a word medical device and if I write it, sometimes I may slip into using a different word like a product, or I'll use something like just a device instead of medical device, but it has a consistency checks on documentation, gap analysis. You can use it for gap analysis. Suppose you have ISO 13485 2016, like you can view the most advanced version. It tells you what are the gaps. It's simple, like it does the same test extraction and see what is the difference between these two. And it provides you what's the difference between this document and this document, and that we take them so seriously, like. But I mean, it's doing a really serious work within 5 minutes, which for us will take 2-3 hours to read both documents and find. There are also risks, like sometimes it may lose the context. It may interpret the same context in two different situations. That's okay. And these are all because of the bias in training data. That's what I said. Training data is something so important that I could say the crux of any successful ML model is the data. Okay, that's the training data. It should not do over automation. Take decisions of itself. Okay, it can be used up to certain level. If you over automate it, say NLP linked to deep learning or CNN or something which take decisions. Okay, and also tells you the root cause, whether it's a complaint or not a complaint, and it keeps providing the root cause, whether it's COPPA or don't over automate it. You can limit it to one activity, two activities, combine two models. Okay. But you should be having your finger over it or monitoring it. And sometimes this is bit funny, like it gives a false confidence that it is very correct. Okay. But sometimes it could go absolutely wrong. I tell you, I have a lot of experience on it where it gives you, I mean, we think that it is right, it's telling something really right. Okay, when you think, and when you read it second time or third time, you feel that there is something wrong, absolutely wrong with this, what this model has provided. So we need to validate this. As a training and validation are very, very important. Okay, and change management. Suppose if you are providing other trained data, okay, for training you're providing new data, or you're adding some new data to already trained model. Okay, you need to see how they are combining or totally providing new training data. Then that are some of these, because I said it may drift. Drifting is like it may go outward, not really providing the necessary in the sense the ground truth or the actual truth of that. In ML we call it as ground truth. Okay, ground truth is basically taken by us, or in diagnostics, the physicians. That word is called ground truth, means the reality, the human intelligence where it plays. That is called ground truth. Okay, so change management and drifts this happening go away from the reality of ground truth. Okay, and something like if you keep adding new terminology, I said new training data, new regulation, new failure modes. Okay, you need to work on change management and see whether it's drifting or not. Okay, drift over time as you keep working for a large time, because the nature of complaints change. Or not only I'm talking about complaint, we use for other activities also. The nature of it, the nature how it applies your training, the pre-trained data, okay, changes from what's available real world. Okay, that's one of the main problem when you keep ML models in the real world, is that real world, like real world is something like you have a lot of combination of variables which you have not used or use them in your training. Okay, like suppose I say for a PMCF or a clinical investigation, okay, we have a lot of variables. Suppose I'm using an implant for a patient, say cardiac patient or orthopedic implant. we need to look into a lot of variables like the age, body mass, BMI, a lot of things, diabetic, hypertensive, all this. But you need to understand that all these variables, 15, 20 variables are being fed into that, and you have trained, and the model is aware of that. And if you're not done, and you're providing your text data with these variables, like, okay, he has some comorbidities, then there will be absolute drifting of it, because it doesn't understand what are these comorbids, like what is diabetes or linkage with diabetes and hypertension, how it affected the device. Okay, I mean, this basically happens in our manual work also in human intelligence. That's why we use real world data as a classical example. Okay, not the controlled clinical data. Like, you have what we call inclusion and exclusion criteria. Okay, what is the inclusion criteria for the patients for the study? It's more a controlled one. I exclude a lot of them, lot of things, or lot of variables, lot of patients, because I want my clinical data to come out clean and successful. Okay, with no risk. But in real world, it's very different. You have a lot of variables, lot of variety of people with lot of combination of variables, age groups. I mean, you talk of anything, but that has to be done. You need to show the model, the real world, not just a controlled trial that's happening. And this is what we used in regulatory positioning. Automated text analytics are used to support review and trend analysis. Final interpretation and decision remains under human control. This basically you can copy paste this in most of it. This will change. The first sentence will change, but the last one will remain same. Okay, the final interpretation decision remains under the human control, but you need to explain. That is what we call explainability. The most important thing is the explainability of your model. Okay, that you are responsible for it and you have taken the decision. Of course, it has done some of the work. That's quite important. Okay, this just give me a couple of minutes, just 2 minutes. Oh, no, I had a bad throat like. Okay, we'll try to understand what is, I said, LLM or more advanced, perhaps I could say, I mean, leap and bounds more advanced than NLP. But let's see what is the difference between NLP and LLM, and what is the use case. Of course, the use case could be looks something similar, but they do a lot of advanced work. And let's do the comparison of it. And the core concept of working basically remains not the same. It could be similar. Okay. This is an advanced NLP model trained on very large volumes of text to predict the next word. Okay, next word is in ML we use word we name it as a token in a sequence. Okay. What it does is, I know like it has a lot of data. I mean data that it has been trained on. Okay. What it does is it can predict what the next word could be in a sequence. Apart from NLP, this is something which is additional. What it does is it can predict or it can understand what the next word or the next token could be. Because LLM does not reason, understand, or verify truth. It predicts what text is statistically likely to come next. So what it does is, when I say statistically, it's a very important word here. Because it is trained what the next word or the next sentences could come as, or what the next tokens could be. It's been trained on that. It's not like it's having some intelligence. It's being trained. Okay, with large volumes like what you use in generative AI. Okay. But I mean, the fact is, it doesn't understand what you really mean, what is the truth. Okay. I may type something and it provides me a lot of information, or may I expect like what I will be doing, or what next I'll be doing. Because if you see, I mean, if somebody has worked in ChatGPT, okay, you will find like after it gave all the context or what is required, what we have prompted, it will also provide options for us. Like you have another option. Can you further work on this? Suppose I say, let me provide a clinical evaluation or literature of a particular device or an implant or a stent. It gives me all the stunts, and again it gives me 3-4 options, because it can understand what next we want it. What is he trying to derive from this? Okay, without our next prompt, without providing, it gives us options like you want this. Or should I convert this into a PDF or do something or provide some extra information on that? That's what it understands, what context we are working on, and predict what he's trying to work on next. Okay, sometimes it may go wrong, but mostly if you work on ChatGPT or Gemini, don't do it. Gemini also sometimes does it, but ChatGPT more often does this of providing a lot of options after your work is finished. Also, it tells like you want anything, this is what I can provide, because it already had it. So you keep spending time on it. Okay, let me also look at this. Then you say, okay, go ahead, or proceed, or option one, something like that. And after the completion of, you keep extracting a lot of this, what you actually want and don't want also. Okay, because it is already having the data, so it gives you till you get exhausted and close it. Okay, I mean that's the beauty of it. Like So everything on an ML does emerges from this single capacity. Why MML exists? The traditional LP system has this problem. They require task-specific models. Where traditional LP system, they are very task-specific. Like I want to know what are the complaints. Okay, do the risk classification or risk stratification of the complaint. Will give me the probability, or give me the severity index of the complaints, or some other work on EMS or something. Okay, a specific talk, but later you can link it to deep learning and all this stuff. But here what's happening with LLM is that it can handle a lot of stuff. Okay, it can ask you like, okay, you have a complaint. I have done the risk stratification or risk classification. What it asks, would you like me to make the complaint, make it as a complaint that has to be reported to regulator, what called regulatory advisory board, should be reported to the regulatory, or we need to work on the kappa or do a root cause. Then it asks like, okay, shall I do the root cause analysis? Tell you what is the root cause analysis. It okay, we'll go ahead with RCA. Then it gives us a lot of after the RCA, it gives you a lot of op. So it is so much connected that it provides everything in one model. That's why LLP is more a deep learning, which is connected with a lot of models. Okay. Here you need heavy manual integration. You need to integrate it with manual, but this does more. It only gives you an option. Just you need to say proceed or option one and all this stuff. So it's difficult for it to work across the task. Like, okay, one task is only complaints, classify the complaints. What are the risk classification? Okay, and if I take it further, give me also the root cause and also provide me a kappa. It may find difficult or sometimes it may not do. Though you integrate that with the deep learning. Okay, because LLM itself is a deep learning. Okay, NLP is a not deep learning, it's more an unsupervised learning. Okay, it comes in between deep learning and unsupervised learning. But LLM as such is a deep learning one. Handles many language tasks with one model, adapt to new tasks with minimal configuration. Okay, generate fluent human-like text at scale. Just recollect what you are doing in the chat or in generative AI or GPTs. Okay, these are large language models. But the problem with them are they are very general. Okay, these are not specialized until you train them, okay, for some specific task. What I'm making to understand is like NLP, you need to connect a lot of other models to complete a series of tasks. Okay. For example, I told complaints only. Till you need to integrate it with deep learning or CNN. Okay, you need to further integrate with a classification or logistic regression. Well, then you need to go back to the supervised model. So it is a series of things which we need to integrate. But in LLM, it performs, one model performs all the tasks. Okay, with minimal configuration, you don't need a lot of coding of the language. Okay, that's the advantage of with advanced models like the LLMs, the advanced models. Okay, you don't need to do a lot of coding or write like what we do in Python. Okay, I mean that makes these ML or AI models very interesting. That okay, the coding of late, many people are learning this coding within 3 months. Like it's becoming so interesting. Like Python is very easy to learn and you can code it. Okay. This is a difference. Okay, NLP is task specific, is a general purpose, structured labels. That's what when you label them, it becomes supervised. This is free from text, or there is no need of labeling for you. It's very narrow, specific task. It's very broad. Explainability is higher. Yeah. Okay. You need to explain a lot of things, but the advantage here is you have lower explainability here. Okay. The risk is more localized. So your explainability may be low, but the risk is systemic. Can somebody tell me why the risk is systemic? Just one second. Hi, Naresh. Yeah, good. Yeah, it's okay. अच्छा. Yeah, sorry guys, it's an important call. Oh, from an important person in medical area. So this is what, just give me another 15-20 minutes. I'll complete this LLM, but I really want to touch upon, I mean, genetic AI agents and agentic AI, which you will feel really interesting, like how it works like a human. See, individual tasks, individual models work, okay, like how we work individually. Okay, we may have a team, but basically we do works individually. That's how the models work. But agentic AI or AI agents, they work like a team. Okay, they have autonomous. I know the risks and the dangers of that. When there is some autonomous thing that is imbibed into the model, it may not be really great for medical devices. But in a lot of domains, people are using. I mean, the latest is the agentic AI. Before that came AI agent, and before that was the LLM. Okay, that's what we are discussing. So I think if I have time, I'll touch on agentic AI, or we'll close in 15-20 minutes on LLM, because I already discussed on NLP. It works similar, but the main difference I said is it can predict or conceptualize, okay, work on large data, conceptualize what will be the next task. Okay, it can phrase the next task. If you want to, I mean, remember LLM, okay, just, I mean, on a very superficial thing, remember LLM, just remember ChatGPT, how it works. Okay, it has a lot of options. It's a single model connected to a lot of things. It can generate images, it can do a lot of things. Okay, you know what you'll be asking next. So before that only it will give you a lot of comfort. So manual configuration there is limited. And it's also explainability is limited, but the risk, as I said, I mean, actually I forgot this. The risk is so systemic. Systemic in the sense it spreads. Suppose if the risk arose, okay, from your first pre-model or the first prompt or anything that I'm not talking about GPT or ChatGPT, anything that has worked on your model, you have not properly done it, validated or trained, because a lot of things are connected to it. Okay, I mean, again, I'm taking the example of compliance. It goes to up to the kappa or verification of effectiveness of the kappa, reoccurrence of it, and also do some predictive analytics. So what happens is your total complaint, okay, complaint handling to your predictive analysis goes absolutely wrong. Okay, that's what we call systemic. It spreads. Okay, as I tell many times, in our body also we have systemic infections like blood infection. Once there is a blood infection, it spreads like what we call systemic infection. Okay, something like sepsis. So here also, if there is any risk, it will, I mean, amplify, double on, or it can synergize into other risks. Yeah, synergize not only add another risk, it can synergize. It can become 1 + 1 may become more than 2 or 3. So that's you need to be careful. Here also I said tokenization, core principle. Read sequence of word, predicts the most likely next word. Repeat this step many times. Okay, just remember schedule. Why it repeats many steps next time. You keep on working on it. It gives you options, so many options that either you need to, I mean, exhaust your energy, or you need to, I mean, become hypoglycemic. But it keeps on giving you, it gives this many a times. Okay. And the problem is it gives references, but it may not check facts. Okay, any NLP doesn't do it. That's why in ChatGPT there will be, or in any AIML model, if you work on it, okay, you need to mention at the footer that this is generated by AIML. Okay, but though you verify it, though you approve it, but still you need to mention at the footer this was generated by AIML for those things. Okay, this is something which is the new amendment to the Act, AI Act, which says that because it's generated by AML, which practically means that it is not factual, or it may be factual, but it may sometimes the probability of that being wrong is has to also be accepted. Okay. Validate regulations, it doesn't validate, it provides updates on regulations, but it doesn't really validate. Understand the safety thing, which is very important for our domain, that's on patient safety. It only knows what text pattern usually follow after text pattern. After you give a lot of text pattern, it knows what next comes. And that's also really intelligent. It understands what next comes. It only does before you ask, it provides you a lot of things. Okay. Why it's called LLM is that it can train massive data. Okay. Technical, legal, medical, or general tests. Large models, millions and millions of parameters. Parameters store learned language patterns. It has a memory. It can store, suppose if you work on this generative AI, okay, once you create something, a project like it, it stores. Where it stores is in the data centers, but there is a limitation, like maybe after some time you need to pay for it, or you have to become a member premier, or you need to subscribe for it. Large capability is understandable. I mean, that's what all these MNCs, okay, in AI sphere are earning their money from these LLMs. Okay, like what we discussed, linear, supervised, only few technical people work on this supervised learning, deep learning. LLMs, it's useful for a lot of non-technical persons or for a large varied group of professionals or even unprofessional also. And if you know the latest news, the ChatGPT is coming. Earlier it doesn't have ads when you do some work on ChatGPT. The new thing is it's coming of maybe in a week or 10 days. When you work with ChatGPT, you'll find ads coming in. Okay, based on the content what you are working. I read this yesterday or day before, because these data centers are not able to, I mean, have the capacity to store so much of data that's coming in. Something like per day there will be, I think, like 80 million users of this LLMs, and there are a lot of data, you need data centers. And you know, problem with data storage and center, you need a lot of cooling of the unit, a lot of water, a lot of current. Okay, and if I'm not going to the what is currently happening, like 5% of the total electricity in the world is spent on data centers. Okay, and don't feel happy that data centers are coming to India. Of course, I know, like in Vizag, Vishakhapatnam, where AP Med MTZ is there. It is actually, I mean, data centers are nothing, like it doesn't provide any employment, or it doesn't do anything. It's like elephant in the room, storing the data. We need to provide all that stuff on electricity, cooling systems. Okay, and that's why people are coming to India on data centers, not on the real actual thing, on innovation and research in AI. Okay, it's same thing like here also you have tokens, fragment the words. But it will be interesting, like how we can predict what we are going to ask next, or what is the next token, or what is our next text or sentence. Okay. See, token words are word fragments. Each token is proceeded numerically. Relation between tokens encode meaning patterns. See, this is what we have seen similar in NLP. Important thing is LLM knows the word, knows that words go together, not they go together. It knows how they go together, but it doesn't understand why they go together. That's a problem. But the most important thing, which is interesting in NLP, is the meaning is not symbolic or semiotic, okay, or something like a sentiment analysis or symbolic. There we find it more symbolic, but it is a statistical approximity. This is very, very important. Like, what is the statistical approximity that what could be the next, what he will be asking? Okay. It could be very close, like 90%, we may be asking the same, or it could be zero, we may not ask the same. Okay, when it provides a lot of option, it may be 100% true that it can predict what we will be asking next, what is the text. Okay. Or sometimes we may not ask it also. That is on statistical probability. That's why I'll let you know on what is statistical probability. Of course, we discussed this in on logistic regression on what is the probability. It's not yes or no, or you can lie somewhere between 0 and 1, or 0 to 100 have more probability, or what is the percentage, more than 50% or nearing to 90%. And it has to be interpreted in a different way. That's the job of QARA. It's not like you can still label it. If it is above threshold, you reject it. Okay, you can define what is the threshold. It will say no, it is rejected, or if it is accepted, this is the threshold. You can define it. Okay, that is what we call statistical approximity. It may not be always right, but the statistical proximity will be very close. Okay. But it understands why the words go together. I mean, the words go together, not why they go together. Because if you, if you look very comprehensively, and you can understand this, in a particular domain, I'm working on some system on an LLM. There are chances that we find the same words coming again. So suppose I'm working on a clinical document on a medical device of a particular device, which I'll mention, medical clinical evaluation report. Then immediately after giving the report or some literature on it, it's do you want it as per EU regulations or FDA or IMDR? Because it has understood that this guy is, that's how it's framed. He will know, it will know that he wants it for a regulatory submission for a particular country or for a particular regulatory standard. It will ask like, should I categorize as this, or should I include further annexures? Okay, because this is very interesting. When I read this, I was really shocked. Like, can machines also remember and work like this? Okay. If you close that LLM today and open it tomorrow, it comes back with the same options. Okay. And the proximity of that will be very close. You can check it. And I mean, forget about ML or LLM. Superficially, I mean, in our human stance also, you can understand we have some sequence of words or a group of words. Okay, a phrases just will be very common, we'll use it. Okay, or maybe the verbs, punctuations, all that, commas, all that may be different. But the words or the meaning of the words will be similar, as I said in NLP. The wording, meaning of the word can be similar. Okay, because I find like yeah, there's a problem with this ML. some I mean, I had Copilot some kept it for some work, it suddenly opens. Okay, you can use Copilot tools. Okay, LMs, this we have already discussed. Track long text context. You can give a lot of text. One day, I mean, tons and tons of text, still it understands. Okay, it like that's a problem. It will be like a conversational flow, like I'm talking to somebody who is an expert in that particular subject or domain. When you're working on these LLM models, you feel you are really talking to an expert, that it keeps explaining and other options. You can do this, that, this. And that's why LLMs have become, it's a deep learning thing, but LLMs are becoming so popular. Okay, and millions of people are using it, and the companies are running the millions of dollars out of this. Okay, maintain conversational flow, refer back to earlier statements. That's what I told. It has a memory. You can go back to what you have done 1 month back, and it can track it. Can track long text context. But in reality, the model is matching patterns across, and it doesn't have human intelligence. We know it. It don't remember. It's trained. And this is factual about all AIML models. You will find the same wordings, not similar wordings. The meaning will be the same. Not evaluating correctness or consistency. That's why I said like human interference is very important. Humans have to be the loop. That's why we call it as hybrid intelligence. That's going to be much valuable. Okay, I do agree, like autonomous models has to work on some things which mainly unskilled workers or unskilled employees. That's a worry on unskilled employees on losing their job. Like if some of the work is done like in Amazon, all that stuff. Most of them are become so there's a lot of automation that happen because they are autonomous. They know object detection, what to object to pick up, then what to place. You give order, like I'm talking about Amazon or a certain thing. Amazon is such a wonderful thing that happened. It has revolutionized the AIML in the service sector. Okay, it has its problems. Do not learn all this stuff. regulatory intent, legal obligations, safety. Why LLM output sound authoritative? Yeah, you also find like you find them to be really correct when you read it, and the sentence construction or the way they project is like as if I know everything. I am the Citysco, I am the USFDA, I am a notified body, like I am the auditor. It gives answers in such a language with so much authority. Okay, the reason is that it has a lot of data it can derive, because whatever LLM provides is because of the large data set it has. So what we feel is when it has provided the answer, we feel that okay, it has so much large, what even a human can remember, even in my domain or in a medical domain, it can remember something like has a memory of 1,000 people in what I am teaching now on medical device QARA. Okay, it has so much memory, and so when you have so much memory and you can just tell it in a second, like, okay, Annexure 3 or Article 21, 61, that this, it shows that it has data and showing its authority that I mean, the sentence also will be the same. That's what I'm saying. It's the fluency of how it comes, coherence and the confidence. And it also tells you, you can do this, that, this, and gives you a lot of suggestions. I mean, that is one of the danger with LLM is of you could have read, like if it goes out of control with of late, a lot of people got addicted with this generative AI. They are asking these generative AIs for suggestions. I read sometime like uh, I think it's a fact because I checked the factual news. One person committed suicide because the model suggested, or the GPT suggested, or generated, when he was talking to that model, it more like a conversation. He finally he was asking, and finally that came to a conclusion that you need to commit suicide. You don't have any options. So he committed suicide. So that's, I mean, a lot of things you become addictive, and when it becomes very personal, and there was a lot of editorials I read, like of late people are conversing a lot with LLMs, generative AI than the humans. They're taking advices, suggestions, decisions based on what the ML or machine learning is providing, or the generative AI is providing, then listening to the elders or the humans or who are experienced in this, that's quite dangerous. I know, like this will spoil a lot of youngsters and children. Okay, LLM task, I say it can do all things, but we need to see that it doesn't do some stupid things. Like a draft SOPs, outline regulatory summary, training material, non-final in the sense, since final documentation you need to sign. So consider what LLM provides as a draft, but don't take it as a final one. Just take it as a draft. Okay, it's good. It provides a lot of information within fraction of second. Done a lot of work. I mean, earlier when I entered medical years after my PhD, I mean, I felt very difficult just to write an SOP. It took so much time to understand how to write an SOP. But I mean, I feel that way of writing SOP is much better than what LLM is doing, write an SOP, because I don't understand it. Okay. And once I don't understand the context of how to write a SOP, it is very difficult. Okay, it does a lot of work. I said categorize come. That's why it's a deep learning more advanced. Group context, identify document types, question answering, explain concept, rephrase regulations, support training. There are major risks, like this is what I said, hallucination because of its memory. it may give wrong decisions or provide wrong information. It may invent some standards of its own. Okay, mistake laws. That's why we need to recheck, fabricate the references. Over automation is one problem. This is there. And this is what I'm talking about, data security or data leakage risk. There's some sensitive confidential data, you never use the OpenAI. Okay, though you subscribe it, sometimes there is every possibility. Of late I read it. There's a lot of data leakage that's happening. Not also on the technical things, but basically on the personal domain. There's a lot of data leakage that's happening through LLMs. Personal things from countries to countries is sharing. You know the geopolitics, what's happening. The validation is very important. So, I mean, that's what I mean. Bottom line, whoever two are there, because I'll be sharing this recording. You both remember, as we go into more complex deep learning models, autonomous models, okay, you need to be very careful. One is on the explainability, regulatory compliance, the risks, the limitations, okay, the training of the data. I said the cybersecurity or confidentiality of the data, okay, and governance of your model. All this, once I complete this, I'll also talk a little bit on, I mean, how to work on all these limitations. It's not that we can't address the limitations of the ML models. You can work on that stuff, on what are the limitations, how to address them. Okay, there are ways to address them, but I mean, most of these people working in this sphere don't do that. Yeah, you see, this is not real. If you read this, Europe must define permitted use cases, restrict autonomy, ensure review and approval. Okay, the role of QARA is a common. I will provide in one document all the common audit findings. Okay, this because all of them look similar. Like, and this is one important. You should have an SOP. I'll give you that SOP. When you are using an ML model, you should have a SOP in your system that it defines what you are doing on everything. How you train, where you got the data, how you validate, what the results are coming, whether the human interference is there, who is doing it. Okay, I have that SOP, I'll share you. And this is the difference. It doesn't have all no accountability, judgment, ethics, understanding. Okay, text generation for us is limited. It does a lot of great stuff. Okay, thank you both, Susmita ji and Pranita. I think Pranita, maybe tomorrow we'll meet again. Maybe next Sunday or Wednesday we'll go ahead with this. Will be interesting on AI agents and agentic AI, because this is going to be the future. Of course, I'm not saying the others are not useful, but this is what we call like becoming so autonomous, where we can do multiple tasks at a time. Okay, I mean, that's what important. We need to save time. Time is so important for everybody. I mean, the only thing we can't buy in this world is time. So we need to use time, but I mean, use time properly. So there are some simple tasks which you can autonomize or automate using these AI agents. Simple things, not the complicated ones, which becomes risky or enter into your personal sphere. Okay, thank you guys. Take care. See you tomorrow.
Thank you,
No,
sir.
some I will see you on Wednesday, Sunday.
Mm.
Maybe Pranita, I'll see you tomorrow. Okay, maybe your AMTs would have told you. Okay, fine, guys. Take care. And Susmita ji, I'll come back to you. I'll have one-to-one discussion regarding how we can work further.
Sure, sure. Thank you.
Yeah.
Good
Bye.
night.